Hi everyone, trying to get caught up on videos. So today we're going to be talking about the circumference of a circle. So I'd like you to pause, and if you are doing this without me, I'm assuming that you have friends around. I want you to collaborate, and I want you to draw a circle and name as many parts as you can of the circle. Alright, so here is my attempt at a circle. So what do we know about a circle? I am hoping that you know that it has a center and that every point on the outside is the same distance from the center. And if you have a segment that has endpoints at the center and on the edge, that's called the radius. So we're going to be talking about the radius. If you have a line segment that goes all the way through and edge to edge through the center, that's called the diameter. And again, it is made up of a series of many points that are the same distance from that circle. And eventually, maybe not in this unit, but eventually we're going to talk about how a circle is made up of 360 degrees. Did you come up with anything else? I am hoping that you came up with circumference as well. The ratio of the circumference to the diameter, circumference to the diameter. So the circumference is like the perimeter of the circle, all the way around, all those points. So that's the circumference. And we know through experiments that the circumference to the diameter, so if we take the circumference and measure it out, it takes a little more than 3 diameters. So the circumference to the diameter is this very special ratio, and that ratio is called pi. And I'm really hoping that this is not the first time you've heard this. So since the circumference is a little greater than 3 times the diameter, pi is a number that is a little greater than 3. So we're going to use the symbol sometimes. The symbol is exactly pi. So if I ask for an exact answer, you're not going to use 3.14 or any approximation. You're going to actually just leave it. We call it leaving it in terms of pi. Pi, if we used a calculator, it might look like it ends, but it really is a non-terminating, non-repeating decimal that goes on and on and on and on and on forever and ever. The most common approximations are 3.14 or 22/7, but both are approximations. They are not exact. So the circumference of a circle, we know, is that ratio circumference to diameter, pi, times the diameter length. So the diameter length. So what we are going to spend today doing is practicing finding the circumference. So sometimes you're going to need to use the 22/7, and sometimes you'll use 3.14. Sometimes you'll use the pi key on your calculator, and so you might leave it in terms of pi if you want an exact. So 22/7 is an approximation. So we know again the circumference is pi times the diameter. Again, I want you to write that formula every time, because many times on standardized tests you're not going to be given the formula. So you need to write it down so it sticks in your head. So for pi, we're going to use 22/7. And this is going to allow us to practice our fraction skills. And then we're going to put in the diameter, which is 21 centimeters. And since we are multiplying fractions, I'm going to put a 1 underneath. Now, if you like to multiply across and then divide, you can. I personally am going to cancel out first. So now I just have to do 22 times 3, which is 66. And because it's in centimeters, our units are in centimeters, not centimeters squared, because we didn't do centimeters times 7 centimeters. So it's approximately, that symbol means approximately 66 centimeters. I'd like you to pause and try the next two on your own, remembering to show all 3 steps. The formula, the work, where you're plugging in, and the answer. Alright, let's see how you did. I have my formula. I took my approximation 22/7 and I plugged in my 91 feet, and I already see a mistake, and then I multiplied to get 286, and that is supposed to be feet. Make sure you're paying better attention than I am to your labels. 286 feet. The only time I would use 22/7 instead of 3.14 is if it was something that was divisible by 7, because this is much easier than trying to multiply the decimal. If I had a calculator handy, I probably would be using 3.17. Alright, so then the next one, here is my formula. I plugged in, and again I reduced first, and I multiplied, and I did not pay attention, and this is supposed to be meters. Not meters squared, just meters. Okay, so we're going to do the same thing for B, except we are going to, we don't have the picture, and so we have to read very carefully. So what we know is that the radius is 11.7 centimeters, and we're looking for the circumference, and it tells us to use 3.14. So the radius, the radius is 11.7 centimeters. But in this formula up here, centimeter, circumference equals pi times diameter, we're using the diameter, not the radius. So we need to adjust what we're using. The circumference equals still pi times the diameter, remember, is all the way across the circle, where the radius is only halfway across. So instead of pi times the diameter, I'm going to adjust, and I'm going to say it is 2 times pi times the radius. So I'm just doubling the radius. And I have pi in the middle and 2 in the front just because 2 is a coefficient and it comes first. So 2 times 3.14 times my 11.7. Alright, so when I plugged that into the calculator, and I hope I calculated correctly, flipping back and forth, I came up with 73.476. But this is where we have to read carefully. It says to round to the nearest tenth. So we have to remember our place values. Where the decimal is, the number right after it is the tenths, hundredths, thousandths. Remember, this is the ones and the tens. So we're rounding to the tenths right there. So you look at the number right behind it. If it's 5 or greater, you round up. So my answer is going to be approximately 73.5 centimeters. Alright, the next two are very, very similar to what we just did, except now notice it says you're rounding to the nearest hundredth, and it says to use the button on your calculator. The button on your calculator. So I would like you to try this one. Read this one carefully, because now it says write a formula that expresses the value of C in terms of R and pi, and we've already done that. Can you tell me what the formula is? And then this is about half of one. Half of one. So think about if you only had half a circle and this extra part, how you would find this perimeter. Alright, see what you can do and come back. Alright, let's see how you did. So I used my circumference equals 2 pi r, and I plugged in my numbers. I left pi right here to remind me I wasn't going to use 3.14. I was actually using the pi button. And when I plugged it in, I got a much longer decimal. This really went on and on and on. Because the calculator uses more decimal places, but it's still an approximation. As you know, a calculator has only so many places. So this is still, even though I rounded to my hundredths, it's still an approximation. It does not equal 73.51. It equals 73.51 blah, 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 blah. So it's still an approximation. All right, this we've already done together. The circumference equals 2 pi r. We also know that if we're given the diameter, we can use the circumference equals the diameter times pi. Those are two different ways. All right, let's tackle E. The figure below, so this one right here, is a semicircle. So I told you that's like half of a circle. So my diameter is 8 meters. So now I can go back to C equals the diameter times pi. The diameter is 8, and we're using 3.14. And so we know that the circumference of the whole circle is about 25.12. But we only need half of the circumference. So we're going to have to take that 25.12 and divide it by 2, which is approximately 12.56. But that only got us this part, the semicircle. If we're finding the perimeter of the whole shape, we also need the bottom part. So we have to add in the 8. So the area of this shape, sorry, not the area, this, I'm jumping ahead of myself. Not the area. The perimeter of this whole shape is approximately 20.56, and we're in meters. All right, the last two slides, I would like you to, on your own, annotate, add notes, highlight, because it really is what we talked about in the first slide. It's the relevant vocabulary. So pause and talk through it, or actually you don't even have to pause. You can stop the video now, but I will show it in both places. And annotate and highlight the relevant information that is given here. All right, I hope you took good notes, and we out.